I'm guessing when we threw up the slide that said it was the School of Engineering and Technology, nobody went mass exodus for the door. So everybody that is here intended to be here. So that's a good sign. Things are working in the right direction. Welcome to the ADFA Open Day and to this second presentation of the day on the School of Engineering and Technology. I'd like to start by acknowledging the Ngunnawal people, the traditional custodians of the lands upon which UNSW Canberra is situated, and pay respect to elders past and present. I extend that respect to all Aboriginal or Torres Strait Islanders people that may be here today with us. So my name's Pat Heffernan. I'm the head of school for the School of Engineering and Technology. I'm a professor in civil engineering, and I will be joined in my presentation today by Neda Abuturab, who is the deputy head of school for education and an associate professor in electrical engineering. So I want to start off a little bit talking about our vision. So we as a school, what it is that we try to do and how we try to do it. So a vision statement, if it's well crafted, tells you what we're trying to do, and I think it's fairly obvious by this that what we intend to do is to deliver world-class education, engineering education, and research. That's what we're trying to do. But a very well-crafted vision statement will also tell you a little bit about who we are and how we're trying to do it. And if we look at our statement then, we intend to do this by the creation of inclusive communities. And I could even go on and add to that and say that we're trying to do it through the creation of inclusive, innovative, and creative communities. So what does that mean? Who is our community? Our community is everything from external stakeholders to internal stakeholders, other schools within the campus, our academic and professional staff which support our programs, our higher degree researchers, students, and our undergraduate students, and just about anybody else that you could imagine that touches on the life of what we do and deliver. Okay, so we know who our community is. How do we empower them to deliver so that we as a collective provide a world-class engineering education and research? We do that by making sure that that is a supportive community, that they are encouraged to be innovative, that they are creative in what they do, and committed. Because it's through their individual success, their individual achievement of excellence, that we as a collective deliver on our vision statement. So that's a little bit about who we are. Now, University of New South Wales has our values in action, or which describe the behaviors that we expect of all of our participants, all of the members of our community. So let's break it apart and see what we see inside. So the values then, as they're described, so we build up on the embracing diversity, as well as demonstrating respect for every member of our community. On these two fundamental foundational values, we're able to start to build the collaborations that we need to be individually successful. What does individual success look like? Innovation, driving for innovation, trying to find new and creative ways to do what we do, which of course in our school is engineering, and that allows us to demonstrate not just individual success, but collective success, or excellence, sorry, success which is demonstrated by excellence. So if you're in the room today, probably within your little group, there's somebody who's thinking about being an engineer, and you're trying to figure out if it's right for you. Now, you may be here because mom and dad said you should be an engineer, let's go. Or you could be here because you said, Mom and Dad, I think I want to be an engineer, come with me. Okay? Regardless, it doesn't matter what brought you to this room, you're thinking about it. It's on your mind, you're intrigued. So let's have that conversation. What is it that engineers do? Think in your mind the words that you would use to describe what you think engineers do. Now, it's always an interesting question because even in those first early years of engineering education, many people still haven't quite figured out what it is that we do as engineers. So think of those words, and I bet you would find at least a couple of them in this little mini word cloud that I brought up on the slides. Right? All of these play some part in what it is that engineers do. It's not all-encompassing. There's so much more to it, but it starts to have the conversation. So what I sought to do when I built this slide was to say, how would I break this down into one sentence that describes what an engineer is? And flawed as it is, this is what I came up with. Okay? So engineers apply science. In many places, engineering actually is synonymous with being an applied scientist. We apply science in order to deliver the technological solutions. So solutions tells you we're about solving problems. Find a problem, find a challenge, and we want to solve it. And we're going to solve it by technological solutions through applying science, and it is through that that we're able to sustain society, right? Keep it going, but also propel it forward into the future. So what does it look like? What does the path look like? So we are creative problem solvers. I'm going to talk about this a little bit more later, about how broadly your skills as an engineer are how broadly you're able to apply them. This is the traditional path that's laid out. So you're in school, high school, college, you have a strength for maths and sciences. You're hopefully intrigued by technology. And these are the programs that we offer within our school. So we have disciplines of civil engineering, aeronautical engineering, mechanical engineering, electrical engineering, naval architecture. Okay? And we can look and see, well, what does that lead to as far as future employment? And we see employment in industry, we see employment in government, we see employment in defense. There's really nobody there, right? Or nobody missing from that list. It's all encompassing. There really is a job for an engineer just about everywhere. So serene. Yeah. Nah, it's going to play games on me. The only reason why it's pausing is because the animations in the slide, believe it or not, as simple as they are actually taxing the CPU and the computer just a little bit. So it may or may not come up, but it doesn't really matter because I can talk to it anyway. So if you're thinking about being an engineer, what I've described is intriguing you, then you have to ask yourself, is it right for me? Do I want to be an engineer? It's okay, I've got it, Netta. Okay. Is it the right thing for me? So as I pointed out, if you're intrigued, or if you have a strength in math and sciences, you're intrigued by technology, and the text at the bottom of the slide says, and you want to apply that technology to make the world a better place in a real and meaningful way, then poof, up come the electrical generators, and they're all turning and having a good time. Then maybe this is the right thing for you. Need the Adams computer here. Okay, so imagine yourself with a degree from UNSW, a degree in engineering. What does that mean to you and your future and your options and your everything that you can achieve? So let's start with the degree. World-class university, an engineering degree. I'll show you later the demand for that degree in society. You're sitting on top of the world. For those of you that are looking at the defense option, which I assume is probably the majority of people in the audience today, you're going to combine that with the soft skills, the leadership skills, the organizational skills associated with military education and training. That is an incredible duality which will propel you to incredible heights if you're willing to reach out and grab them. Engineers, we shape the future. How do we do it? Some of the things that we do, we improve efficiency, enhance performance, decrease costs, right? And in all of that, we're maintaining the competitive edge. Boost sustainability, because it's not good enough just to take care of today. We have to take care of tomorrow. We improve reliability in our machines and in our technologies that we're employing. And it is through the application of science that we seemingly make the impossible possible. Now, why does that make sense? Because imagine the technologies that you're using today in your grandparents' day. It would have been the magic or the science fiction of that time. The same will be true 100 years from now. If you could take the technologies that you, as future engineers, will develop, it will seem like magic to us here today, if we could just see it. So we contribute to the happiness, health, and safety of society, and we do that from the largest and tallest of skyscrapers right down to the smallest of medical machines and robots, all in the domain of engineering. But that's all kind of big picture, right? I mean, in the end, you want to know, are you going to have a job that will pay for the mortgage, that you're going to be in demand, you're not going to be looking for a job? And so what I want to present to you here on this one slide are the pragmatic side of what it means to be an engineer. So I'll bring up the first three bullets. These are from Engineers Australia and one of their most recent reports. So what does it say? As you can scan through the words there, it basically says we need more engineers. Not only do we need more engineers, we need even more engineers. There is a shortage of engineers within society. We need more of them. There's vacancies in jobs. It is the right time to pursue an education in engineering. So the next two bullets, what does that say? Strong employment outcomes. That's kind of academic gobbledygook for you get paid well and you like your job. Okay? So good time to be an engineer. You're going to find a job because we need you. You're going to get paid well to do that job because we need you. And you're going to enjoy that job because you've lined up your natural attributes and desires and interests with something that exists in the job. And finally, and this is one of my favorites, engineering skills and experiences are highly valued and transferable to various fields. I'll be the first one to tell you that if you graduate with an engineering degree and you never spend a day applying that in a design office or somewhere very pointy end of engineering, that degree is not wasted. Because we're going to give you a whole series of learning outcomes which combine into the attributes that we want to instill in you to be an engineer and to be a successful engineer. And those attributes make you a valuable commodity in almost every field that's out there, whether you're in engineering or in management or leadership or government, it really doesn't matter. You've been well established and set up with the winning tools to be able to take on those challenges. So that's all big, heady. Hopefully you're intrigued. Nobody's running for the doors. So with that, let's get down to some of the fundamental details that it takes in order to become an engineer. So I'm going to get Netta to come up here. She's going to talk us through our programs and some of the entry requirements.
Thank you, Pat. Is the mic working? Just doing a test. Okay, perfect. So I hope that by this point in the presentation, you're feeling even more excited and confident about pursuing an engineering program. So in this section of the presentation, I'm going to walk you through the different engineering programs that we have, show you the program structure, the courses, and basically provide you with more details about each one of our programs. Okay, whether you have an interest in designing aircraft or intending to become aircrew, including pilots, designing bridges and infrastructure, advancing electrical or electronic systems, building machines and manufacturing, or designing marine vehicles, we have a program for you. At UNSW Canberra School of Engineering and Technology, we offer 6 undergraduate programs, 5 undergraduate Bachelor of Engineering Honours programs, Bachelor of Engineering Honours in Aeronautical Engineering, in Civil Engineering, in Electrical Engineering, in Mechanical Engineering, and in Naval Architecture. We also offer a Bachelor of Technology program in Aeronautical Engineering. All of our programs are face-to-face programs. They are delivered on this campus, UNSW Canberra at ADFA. Our Bachelor of Engineering Honours programs are 4-year programs, and our Bachelor of Technology in Aeronautical Engineering is a 3-year program. All of our programs, including a Bachelor of Engineering program, a Bachelor of Technology in Aeronautical Engineering program, they are accredited by Engineers Australia, and they incorporate industry work experience. So it means that as soon as you graduate, you can start working as a qualified and accredited engineer in your field, which is recognized in Australia and many other parts of the world. We accept defense students as well as non-defense students in all of our engineering honors programs, but Bachelor of Technology in Aeronautical Engineering is only open to defense students. Okay, so let's talk about the structure of our engineering program. So in this slide, I'm going to provide you with the general structure of our engineering program, and then we go through each program individually. Engineering follows a very structured curriculum. So what happens that first year and some of the second year courses are very heavy on the foundational knowledge courses. These are like courses like engineering math, engineering physics, introduction to programming courses, computational problem solving courses. These are the courses that provide you with a solid base, the solid grounds that you need for your engineering studies. The rest of the second year and your third year are all about the core of engineering theory and the fundamental concept that you need for that specific engineering discipline. So they provide you with the fundamental topics, fundamental knowledge that is required for your chosen engineering field. We also have design and project-based courses. Engineering is a hands-on degree, so throughout your degree you will participate in different project-based courses. These are more hands-on, open-ended courses where students usually work in teams, sometimes individually, and basically they undertake a design and build project and deliver a product and engineering product. Towards the end, some choices will be added to your engineering program. These are what we refer to as engineering specialization or technical elective courses. So you would have options, a range of options available, and then depending on your interests and your future career goals, you choose what courses you want to do. You can basically tailor your engineering education to your interests and your desire and your future career goals. All of our students do Introduction to Cybersecurity and 2 general education courses from various fields, just broaden their knowledge. And also as a component of all of our honors program, a student undertake a year-long capstone engineering research project that's referred to honors thesis. I'm going to talk about all of these components in more details when we talk about our programs, but I just wanted to provide you with this general structure. The course names differ from program by program, but there are some features that are unique about our program, and I basically use each one of our programs to highlight one of these features. They apply to all of our programs, but I don't want to repeat everything again, so I just probably use each program to highlight some of these features. Let's start from civil engineering. So civil engineering is about planning, design, construction and management of civil facilities of all types, roads, buildings, bridges, water supplies, airports, and so on. Okay, this is slide showing the program structure of the civil engineering program. I invite you to take a look at this program structure. What I actually would like to highlight here and use this program as a sample, as an example to highlight, is the very specialized core of our engineering programs. You can see many specialized courses like soil mechanics, hydraulic engineering, transportation engineering, environmental engineering, design of concrete, so many very specialized courses. These courses are delivered by world-class academics that do bring their cutting-edge research to your classroom, their expertise to your classroom, and basically use that to inform their teaching and share it with you. And this is the same for all of our programs. As we basically go through the program, you can take a look at the core of our program and see, we offer really specialized, globally recognized engineering programs. Okay, next one. This is slide showing the aeronautical engineering program structure. Again, I invite you to take a look at the program structure here. But the feature that I want to actually highlight here is and talk about is the engineering work experience component of our engineering program. That's incorporated in the program, and you do this industry work experience during your degree. And this is a very crucial part of the engineering programs, because the engineering program is all about the practice application of the science in solving real-life problems. So basically, in the work experience components, our students take what they've learned in classroom, take it to the workplace, and see how it is implemented. It's a valuable skill. Our students in the Bachelor of Engineering Honors Program, they complete 60 days, at least 60 days of industry work experience. And for the Bachelor of Technology, it is 40 days. Our students usually do their engineering work experience during the summer that they are going from their second year to third year and from third year to fourth year. Our Bachelor of Technology and Aeronautical Engineering students usually do it in one batch in one of the summers. And again, this is the same, like, this applies to all of our program, but I just wanted to use the Aeronautical Engineering program as an example here. Now that we are talking about aeronautical engineering, I would also like to show you the structure of our Bachelor of Technology in Aeronautical Engineering program. This is a 3-year program, and the work experience requirement of this program is 40 days. Pretty much the 3 years of this program is the same as the first 3 years of the Bachelor of Engineering honors in Aeronautical Engineering, with a slight modification. Okay, but this program is designed mainly for those who intend to become aircrew, but at the same time they want to have a solid background in science, technology, and engineering. The next program is the Electrical Engineering program. And again, I want you to take a look at this program structure. The list of the courses, you see the courses vary from program to program, but the structure is pretty much the same. What I would like to actually highlight here and talk a little bit more in more detail here is the engineering specialization courses. What we, in our programs, we usually refer to as technical elective courses. So the technical elective courses are the choices that are added towards the end of the program for you to basically decide a specialization, decide what sort of expertise you want to develop in your program. And I just wanted to show you the range of options, the range of courses that are available to our students. And they vary from program to program. I mean, the courses are different from program to program, but for every program, lots of options are available. For electrical engineering, for example, here you can see in these tables that are highlighted at the bottom of this slide, courses like radar techniques and application, smart grids and renewable energy, satellite communications, electrical and mechanical plant, cryptography, nuclear propulsion and its assurance, computer languages and algorithm, and also multidisciplinary streams, courses in multidisciplinary streams such as space, multiple courses under space stream, multiple courses under the robotics and autonomous systems stream, and also multiple courses under the artificial intelligence stream. This is just to name a few, and I wanted to give you an idea, and the same applies to all of our engineering programs. Okay, next is the mechanical engineering program. So mechanical engineering program is about machines. It's basically about design, manufacturing, and maintenance of all different types of machines that we use in our everyday lives. Again, I invite you to take a look at the program structure here, but the feature I wanted to actually highlight here is the design and project-based courses that we offer throughout the programs, and this applies to all of our engineering programs. So these are the courses where students, usually in groups or sometimes individually, undertake design and build projects. And these projects are defined, uniquely defined, usually every year, and they basically help our students to take the knowledge from the other courses and apply it to implement or undertake close to a real life engineering problem or project. Just as an example, in our second year elect and mech and elect design course, which also exists in the aeronautical engineering program and naval architecture program, our students participate in the international Warman Build and Design competition. So as part of this, the project that they do in this course is the International Warman Build and Design project, and we have been among the finalist teams many times. This is an international competition. And we have actually won podium places several times. Last year, our students won the second prize, the international second prize. in the Warman competition. And this is basically just some pictures of our students' projects works. Okay. And our newest program is a naval architecture program. So this program is about machines, but machines that go in or on the water. So it's about design, building, and utilization of the machines like ships, boats, submarines, or any marine vehicle. It draws on a wide variety of skills and also covers most of the engineering disciplines. The first 2 years of this program is the same as the mechanical engineering program, and then it starts to specialize in the very specialized in the third and fourth year of the program. What I would like to actually highlight here is the honors thesis component of our engineering program. So all of our engineering program are engineering honors programs, and the last year of the engineering program is usually referred to as the honors year, and during the honors years, the students undertake a year-long honors thesis project. So this is a significant engineering research project that students undertake, and they work one-on-one with academic supervisors in their areas of expertise to basically build and design a significant engineering project. I wanted to actually show you some of the areas, some of the broad areas that our students have been doing thesis in. And this is a non-comprehensive list of the broad areas. And I invite you to take a look at this list and see if you can find something that is of interest to you. I hope that you found something that sounds interesting. These areas and many other areas, many more, are the areas that our students have been doing on their undergraduate honors thesis in. And if you come and study with us, you can also choose from these areas and many more to do a thesis and work with world-class academics that are expert in these areas to do a significant project, research project. Okay, let's talk about the undergraduate student profile. So what's the typical sort of a study load? The typical full-time study load at the UNSW Canberra in the engineering program is 4 courses per semester. Our courses are measured in units of credit, and each course is 6 units of credit, so the full-time study load is 24 units of credit. In terms of the commitment, it's basically you'll be spending, if you do 4 courses, you'll be spending about 3 to 5 hours per day in class and about 3 to 4 hours outside class to prepare for class, to do your assignments, and prepare for your assessments. The normal workload expectation is about 150 hours per semester per course. So the 4 courses, if you do 4 courses, are going to be about 600 hours of workload. And if you just divide it by the number of weeks that you have in the semester, so that's about 35 to 40 hours per week. So that's basically why it's the full-time study load. Okay, now let's just see where you can find employment if you do an engineering program. So basically, Pat has already mentioned and partially answered this. Lots of employment opportunities are available to you as a graduate from UNSW Canberra engineering programs, both in service and in the civilian sector. So opportunities are available in defense industries, in organization, government organization and agencies, in the private industries, in consultancies, startups, and many specialized organization and places, companies that you can work in. What I want to actually highlight here, and you can actually read from this slide, is the logical alignment between the position, especially in service jobs and positions that are available, roles that are available to our graduates, with the program that they have done, the engineering degree that they have completed. This is very unique to engineering programs. So this sort of logical alignment is very unique to engineering program. It does not really exist in other areas. So for example, you can see that if you have someone has done aeronautical engineering, they can, in service, they can become aerospace engineer, aeronautical engineer, avionics engineer, aircraft electronics engineer, armament engineer. And in the civilian sector, they can also work where all of the options that are mentioned plus specialized options. They have a specialized employment options such as airlines and aerospace organization, both military and civilian. So engineers in general have got graduate capabilities that are transferable and they are highly valued by employers. So they can work in any of these industries plus many other options that are going to be available to them. For Bachelor of Technology in Aeronautical Engineering, so this is, as I mentioned, the program that's designed for those who intend to become aircrew, and it's only available to defense students. And the options you see in services, you can become pilot, helicopter mission commander, helicopter pilot, aircrew, mission aircrew, and mission control. All of these options are in service options. For civil engineering, I invite you to take a look at this slide and basically check all of the interesting options that are available in addition to those general options that I mentioned earlier. Same goes for electrical engineering. Many options are available, both in service and in the civilian sector. Mechanical engineering. And naval architecture. Many exciting opportunities exist for our graduates. So this was all about our undergraduate program. I also would like to highlight that we also offer postgraduate programs. We offer postgraduate program in space engineering, space operations, capability management, project management, and explosive ordnance. And if you want to continue further, you can do PhD in different engineering fields, as well as professional doctorate programs. Okay, now let's talk about how to apply to UNSW Canberra. If you are a prospective trainee officer, you have to follow a dual admission process. Okay, so you have to go through the defense process as well as university process. The defense process usually starts early, so we encourage you to start the defense process early, maybe before the midpoint of year 11. Through Defense Force Recruiting. You need to contact Defense Force Recruiting, go through the process, which is the defense process. But the university process is like any other universities in Australia. You apply online through UAC for UNSW Canberra programs. Okay, and hopefully you get an offer from the ADF, Australian Defence Force, you get an offer from for UNSW Canberra from UAC, and you accept the offers and you can come study with us. If you are a non-defense student, the application process is just a single-step application process, single path or single process application process. You just submit your application through UAC like any other universities in Australia. And there's also another scheme. You can apply for the Faculty of Engineering admission scheme, and you can receive points on top of your ATAR. Basically, if your ATAR is within 7 to 10 points of the required selection rank, we will evaluate your ability in maths, physics, and other sciences, and also your passion and motivation for engineering. And you can get, you can receive an early conditional offer with an adjusted ATAR requirements. And hopefully you get that offer, you accept it, and then you can come and study with us the next year. So I strongly recommend, if you're a civilian student, I strongly recommend that you apply. That's also sometimes referred to as the portfolio submission. You apply for the Faculty of Engineering admission scheme because that can just boost your application. It's not going to hurt. It can just increase your chances. Okay, and before I wrap up this section and hand over to Pat again, I wanted to also talk about the academic entry requirements. The 2024 lowest selection rank for our programs for defense has been 85 plus defense process, and for non-defense students 90. Okay, but let's define the selection rank. So the selection rank is basically your raw ATAR calculated from your year 12 results plus the adjustment factors. These are the additional points that you can get on top of your ATAR. And they differ for different programs. So I would strongly recommend that you speak with SAS or check online to see what adjustment factors are available to you. Some of these are automatically calculated through your UAC process, but some of them require separate applications. So please check those. You can get bonus points on top of your ATAR. And with that, I hand over to Pat.
So thanks, Netta. So hopefully that was useful to you. You see the program that's aligning with where you think you might want to go. So now that I've talked about engineering and Netta's walked us through our programs, I want to take just a few minutes, saving as much time as we can for questions, to talk about why engineering here at the UNSW Canberra and at the School of Engineering and Technology. So what's great about our programs? I'm going to start with right up in the title and highlight that. So it's almost a tagline for us that we offer all the benefits of a world-class university with all of the advantages of studying at a small campus. What does that mean? Why is that advantageous? Most big or world-class universities are big. With big comes advantage, but it also comes with disadvantage as you get, in class with 1,000 of your closest friends. What we offer you here is the best student-to-teacher ratio in all of Australia. By nature of the Australian Defence Force Academy construct and how we build our classes around it, you will get to know your tutors and your teachers on a personal level. They'll learn your name and they will learn to care about your development. And in this way, you will connect with your educators and get a meaningful education out of it, greater than you could do in other circumstances. Now, back to the big. It's still world-class. So UNSW, number 19 in the world for the second year running, according to the QS World University Rankings, number 7th by the Times Higher Education Rankings. Okay, those are big numbers. And what it means is that we're giving you the full package. You're going to study from world-leading experts in every field and discipline that you could possibly choose to study. Okay, we're first in Australia for engineering. And we were voted the most entrepreneurial university by the Financial Review. And we run programs, we talk about founders and launch and everything else because we push the entrepreneurial spirit into our programs. Now, back down to the small. You see on the slide, there's some pictures of some of the teams, and those teams can give you great connection, vertical integrated learning, as we like to think of it, where you use those opportunities and those exposures to make sense out of the theories that you're learning in the classroom. I don't know if you've taken the time out in the quadrangle there. They've got the racing team, and I know Aero's set up. There's a lot going on. Do the big universities, we are a big university, the big campuses have all of that? Absolutely they do, but you need to compete to find a spot. And sure, you need to compete to find one of our spots, but you're competing against a lot fewer students. And you'll find a home. If there's an activity out there that you think that would really sink home your engineering education, you have a good chance of participating in it while you're studying here. Finally, because we're a big world-class university, we have all of the academic and well-being supports that you would normally expect to see in a university of that level. And so you will be supported, you'll be taken care of, we do the tutoring, we do it all to make sure that you have the best opportunity for success. So UNSW is a member of the prestigious group of 8 Australian universities, which is to say we're research intensive. Right? All of our academic staff are leaders in their field, producing research that is meaningful to society, having impact on society, and they're going to both use that to inform the teaching that they do in the classroom, and through your honors year and honors programs and that, you're going to get a chance to participate in it, which is a great opportunity. So with great engineering programs come great facilities. We can't do this without the facilities to support it. We have over 100 teaching and research labs within the school, and I show you just a small handful of them, of things that you may get exposed to while you're here, depending on what program you're studying. And finally, we get down to the location in Canberra. Canberra is really beautifully centered. So here we are. We've got Sydney, 2.5, 3 hours away. We can get to the coast in a couple hours. You can even get down to the snowy mountains, which feeds to this Canadian who needs to get skiing every once in a while just to feel like he's not that far from home. We really are in the absolute center of just about everything that there is to do. So just one little tidbit. Over here on the right, we have the top cities by quality of life scores, as shown by Oxford Economics, and Canberra is number 2 in the world right now for quality of life. So if you want to live in one of the best cities to live in the world, in the middle of just about everything going on around us, it's not a bad place to choose. The last thing I want to do before closing up and getting on to questions we'll be joined by a bunch of our students, both training officers and civilian students, to help us answer questions, is to make a pitch for YOWI. So YOWI is our Young Women in Engineering. Okay? It's no surprise that women are underrepresented in STEM and engineering fields. So this is a program that we continue to run. We'll continue to run for quite some time, so that if you're a young woman in high school between 9 and 12, and you're intrigued by STEM, but you don't know what to make of it, come out and join our program. It's a 3-day free workshop that we run during the school break, and we will engage you in a whole bunch of activities that will let you feel supported within that STEM community. We've had great luck with people going from YOWI into both our programs and other people's STEM and engineering programs, and then staying connected with the people that got them all started. So if you're fit that demographic, follow the QR code, take a snap, get the EOI filled out so that you get the information as we set the final dates and everything else, so that you can come and participate in that program. I strongly encourage you to do that. So that brings us to the end of the conversation. Hopefully we haven't bored you to tears. To ask our students to come on up and join us up here. We're just going to try to stay clear of the cameras so that the streaming carries on. I'm going to pass them a microphone, or Netta's going to pass them a microphone. They're going to introduce themselves, what year they're in, what program they're in, and that is going to allow us to take your questions and focus them to whoever it is that can best answer it in a meaningful way.
Yeah, g'day guys. I'm Finn. I'm a third-year civil engineering student in the Army. Yeah, I'll pass it over to Liz.
Hi, yeah, Liz, first-year aero.
Hi, I'm Chama. I'm a fourth-year Defence Civilian Aero student.
Hi, I'm Henry, first-year RAF Aeronautical Engineering student.
And I'm Celine, and I'm a Defence Civilian, second-year mech.
Okay, with that, I'm going to open the floor to questions, and we'll try to redirect your question to whoever can make the most sense out of it. Who wants to break the silence? Somebody out there has a question.
So for prospective training officers, they need to actually follow the two processes. There is a dual admission process. They have to go through the defense process as well as through the UIC process. Yeah, the defense process usually starts a bit earlier, like in year 11. UIC process is like any other university, is usually in year 12 or the year before you want to start the program. Definitely. For all of the engineering programs, and I will let our students also talk to you about, although it's not a prerequisite, so you can still get admitted and you're not going to be denied from receiving an offer, it's pre-assumed knowledge. So advanced maths and physics is the pre-assumed knowledge. So basically what it means is that the first day of the university will start teaching you assuming that you have done those courses. Having said that, we provide a lot of maths and physics support to our first-year students to bring them up to speed in terms of like both high school's maths and physics as well as the university maths and physics in the first year. So support is available, lots of support is available, individually, group support is available, but if you're in your year 11, 12, we strongly recommend you to do advanced maths and physics courses that are available in your school. But let our students also comment on that.
Yeah, so I was in the New South Wales school system like you, and I did do extension to math, and I can tell you it helped me get through first year math very, very easily. Yeah, it's a good head start.
Yeah, I can give the alternate. I didn't. I did extension 1 and still found first semester maths easy, and I'm so far semester 2's fine as well. I think if you did advanced, you'd be doing a little bit of catch up. Extension 1 covers all the content. Extension 2, you'll be ahead, as Celine said.
Not particularly. So the daily lifestyle, you usually have like 2 hours set out for your military education and sort of like what you need to do for defence, and then your classes are spread out along the rest of the day. And like if you're not in class, you can either be studying, like go to the gym. There's even a golf course like down the road, so yeah, you can go play 9 holes if you wish. But yeah, does that answer the question? Or yeah, it's manageable. Yeah, definitely.
It varies every single year, but usually maybe like 10 to 20 each year.
Yeah, I would say like 10 to 20 like mechs plus arrows, and maybe like 10-ish LX. Yeah.
LX and civils as well.
Yeah, LX plus civils, maybe like 10-ish, 10, 15-ish. Yeah, so 40 altogether.
Do you guys actually study 3 or 4 hours every day?
They're not going to tell you the truth.
Because we are
To be honest, more. And it depends. I'll be honest, like it's a manageable study load and it's very rewarding, especially if you like this sort of stuff, if you're ambitious about this sort of stuff. And it varies throughout the year, and the important thing is being balanced, and eventually you get used to it, especially when you get into your first year. After a couple of weeks, you'll be settled into it. So there's, if you're really ambitious about engineering and about STEM, it shouldn't be much to worry about. So.
So the one thing I would say about personal workload is it's very personal. It really depends on what you're bringing to it and what you want out of it. And some people will choose the minimal path and other people will need to work a little bit harder than others. So it is very personal, but it is very manageable. If we accept you into the program, we believe you have what it takes to succeed in the program.
So after you join in your first year, you get assigned a group within the Department of Defense, and your work really depends on what department you join into. And usually you do get a preference. It depends on what program you join into, and there's I think 2 different defense civilian programs now. And yeah, it's basically just a technical engineering internship, but it does vary. There's a lot of systems engineering involved as well.
So yeah, so right now there's a program called the STEM Cadetship that is running. They have like temporarily stopped the other one, which is the Defense Civilian Undergraduate Sponsorship. But from what I've heard for the STEM Cadetship, you get to choose your top 3 preferences on which defense unit you would like to go.
And you can also join UNSW Canberra School of Engineering and Technology as a civilian HECS-paying student, non-defense completely, and that would be like any other student at any other civilian university. So that's also a possibility. There are some changes happening to the DCOS program that it's best to talk with defense about what's happening with that program. So I think probably it would be best to get advice from the Defense Force Recruiting and the defense side on those options.
Yep, I'm part of the FSA racing team, so I joined that when I started at the beginning of the year, and it's hands-on engineering, which is great, that especially first year when you're studying those intros to maths and physics, you're talking a lot about all these concepts and not really seeing them in practicality. Semester 2's been great, we're doing some more practical design subjects, but this morning we were creating jigs and setups for the stand outside. Yesterday I spent 3 hours creating 3D printed parts. I'm getting to use the skills I'm learning in real time, and it's been great.
No, I was just going to mention PSP. There's also the physics support program, which is run, I believe, bi-weekly, where we have lecturers and tutors come in and have some one-on-one session it's quite popular and a lot of people find it useful for things they're struggling with.
And also the math programs, the math supports program is available in addition to the physics and math, both of them. Yeah. So as far as I know, it's not possible, so we don't offer that program here. But again, that's about admission, and it's best you ask this question from our student admin services. They are down in Adams in the lobby. You can ask this question from them.
So Extension 2 maths in the New South Wales syllabus would be the IB AAHL. If you're talking about Extension 1, that would be AASL. You probably want to do physics, and then if you're looking defence, maybe some kind of politics course is another HL, if you're interested.
So we're going to have to leave a little bit of time for changeover to the next presentation. So I'm going to take one more question. But before we close it out with that last question, I just want to remind you, we are set up down in the foyer of Adams. Okay, so the school booth is up in the upper foyer. And it is well staffed. You have brochures. You don't have to take pictures of the slides. I know people have been doing that. All of the information is there, stuffed full of academics ready to answer your questions. Is there one last question that somebody wants to ask?
Yeah, so obviously it depends like what degree you go into and then what course you're doing. I've found, so civil engineering, like it's sort of, for example, I'm doing like a bit of geotechnical engineering and like soils, that sort of stuff. And I've found that pretty like, not overwhelming, but like it's been a bit of a like, a lot of content sort of fed into you, and then you're juggling that with like 3 other courses. And yeah.
Okay, initially it will be quite heavy, but it's really nice to see how the courses are connected to each other. So once you do your first year courses, they're related to your second year courses. So it kind of gets easier because everything's a continuation of what you've done before. Yeah.
So I mean, they are rigorous degrees. It's world-class education. You don't get that without working for it. So they are rigorous degrees. They are full, but they're all manageable. I think that's the underlying theme that we heard today, is that all the workloads are manageable. So with that, I think we're going to close this session so the next group can get set up. I hope to see you down at Adams in the foyer and we can have a further chat. Thank you.